My name is Billal Asoufy, and I'll be discussing the Iterator design pattern. I'll be starting off with the intent. The gang of four definition is it provides a way to access the elements of an aggregate object while exposing its underlying representation. In other words, it's used to provide a standard way for a client to traverse sequentially through a group of objects without knowing about the internal representation of the contents. The Iterator design pattern is a behavioral pattern, and it provides better structure for communication between objects. It is also an object-oriented pattern because it deals with the relationship between multiple objects. As you can see here, I have an example of a list class that would call for a list iterator. Now I'll be coming to my motivation. So an aggregate object such as a list should give you a way to access its elements without exposing the internal structure. You might want to traverse the list in different ways, but depending on what you want to accomplish. That's what makes the iterator pattern so desirable. The idea of this pattern is to take the responsibility for access and manipulation of the data structure of a list object and put it into the iterator object. The iterator class will define the interface for accessing the data structure's elements. The iterator object will maintain the state of the iteration, keeping track of the current item, and having a way of identifying what elements are next to be iterated. So these are some related patterns to the iterator pattern. First off is the composite. Iterators are often applied to recursive structures. Next would be the factory method. Polymorphic iterators rely on factory methods to instantiate the appropriate iterator subclass. And lastly, the memento pattern. It is often used in conjunction with the iterator pattern. An iterator can use a memento to capture the state of an iteration, and then the iterator stores the memento internally. Applicability. The iterator accesses the container content without knowing about or using its internal representation. It supports multiple simultaneous traversals of a collection, and it provides a uniform interface for traversing a container contents. These are some consequences of the pattern. It supports variations in the traversal of an aggregate. Every time you want to change the traversal algorithm, you just replace the iterator instance with a different one. Next, you simplify the iterator simplifies the container interface. Iterator's traversal interface obviates the need for a similar interface in aggregate, thereby simplifying the aggregate's interface. Lastly, it's more than one traversal can be pending on an aggregate. An iterator keeps track of its own traversal state, so multiple traversals can be in progress at once. Here would be an implementation of my UML class diagram, and before I can instantiate list iterator, I must supply the list to traverse. Once I have the list iterator instance, I can access the list elements sequentially. The private next function checks to see if there is a head root that exists so it can return the data. The private remove function is if I would like to remove the head node in the list. The private print function prints the head node in the list. The constructor list iterator just sets the root name to name and the root head to a null pointer. The public next function will return the name and the root given and will send it off if needed to the remove function. The public remove function will remove whichever node was selected from the list. The has next function will append a new node to the following head node bus. And lastly, the public print function will print out the list based on the seniority level that is formatted. Here are some of my references that I used, and now I'll jump to my demo. So my program will be displaying how the iterator pattern works within a list. It will iterate through the list and display the members and their seniority within the list. As the subordinates of each member of the organization, it ranks plus for seniority. As a member hires a direct subordinate, their seniority gets lower but stays within that member. Other than adding, you can also remove a member, and if there are no members above it, it will result in them becoming the member of the following subordinate or the head of the organization. So as you can see, these are the functions that I was explaining in implementation on the PowerPoint. And now I will jump into program. So I must supply the list. So I'll do A hires B, B hires C, A hires D. Now I'll print it. As you can see, it iterates through the list and sequentially gives out the output. Since A hired B and D, they will get 1 plus, which means they're directly right under A, and they're the direct subordinates. Since C is under B and under A, it gets 2 pluses for seniority, which makes it lower beneath the level. So now let's see if I remove B. And as you can see, C now, it reiterates and it pops C up the level. And now you can see that C and D are both direct subordinates of A. So now I'll be removing the head node. And that should result in, since C it was the first one as a direct subordinate, it should result in that being the head of the list. And it reiterated and popped it up. And now D is a direct subordinate of C. I remove C. Now D becomes the head of the org and becomes a head node. So it will keep reiterating, and if I wanted to, I can do D hires E, and it will reiterate and go through the list traversally and supply it. Thank you for your time, and don't forget to like, comment, and subscribe.